Introduction. Everything is moving. All right, let's begin with a really important idea in physics, and that is this. Nothing is ever truly still. No matter what object you look at, a desk, a chair, your phone, even ice, the particles inside it are always moving. This idea comes from something called the kinetic particle model, and it's one of the foundations of thermal physics. According to this model, all matter is made up of tiny particles. These particles are constantly moving. Now, how they move depends on the state of matter. In solids, the particles are locked into place, but they still vibrate. In liquids, particles can slide past each other. In gases, particles move freely and very quickly. As energy increases, particle motion increases. There is a theoretical temperature called absolute zero, which is minus 273.15 degrees Celsius. At that temperature, particle motion would completely stop, but in reality, we can never quite reach it. So already, we can say this: temperature is connected to motion. What is temperature? Now let's clarify what temperature actually means. Temperature is not the same thing as heat. Temperature is a measure of the average kinetic energy of the particles in a substance. In simpler terms, it tells us how fast the particles are moving on average. If the temperature is high, particles are moving faster. If the temperature is low, particles are moving more slowly. This average motion is what we sense when something feels hot or cold. So, temperature is about speed of particles, not how much energy there is altogether. Temperature versus heat. This is where students often get confused, so let's separate these ideas very clearly. Temperature measures the average speed of particles. It does not depend on how big something is or how much of it there is. For example, a tiny spark from a fire can be extremely hot, but it doesn't contain much total energy. Heat, on the other hand, is the total thermal energy transferred because of a temperature difference. Heat depends on how much material there is, what it's made of, and how the particles are moving. So heat is about total energy, while temperature is about average particle motion. Particles in action, states of matter. Let's now look at how particles behave in different states. In solids, particles are tightly packed. They vibrate around fixed positions. When the temperature rises, they vibrate more strongly, but they don't change place. In liquids, particles still stay close together, but they can slide past each other. As energy increases, they can overcome some of the attraction between them. In gases, particles move freely and very rapidly. They collide with each other and with the walls of their container. Notice how increasing energy always leads to more motion. Heat transfer pathways. Now that we understand particles and motion, let's talk about how heat moves. There are three main ways heat can be transferred. Conduction happens through direct contact between particles. This is most common in solids, especially metals, where energy moves from particle to particle. Convection happens in fluids. That means liquids and gases. Warm fluid becomes less dense and rises. Cooler fluid sinks. This movement transfers heat. Radiation is different. Heat travels as electromagnetic waves and does not need a medium. That means radiation works even in empty space. Real-world example: cooking a pan. Let's apply this to something familiar. Imagine placing a metal pan on a stove. The base of the pan heats up first because it is in direct contact with the heat source. Particles in the metal gain kinetic energy and vibrate more. That energy is passed along the pan through conduction. Eventually, the handle becomes warm, even though it's not touching the flame. This happens because energy is transferred through the material, particle by particle. Atmospheric convection, weather in motion. Convection also plays a massive role in weather. The sun heats the earth unevenly. Warm air rises because it becomes less dense, creating low pressure. Cooler air moves in to replace it. This continuous movement of air creates wind, storms, and large-scale weather patterns, all driven by convection currents. Everyday radiation is all around us. Heat from the sun travels about 150 million kilometers through empty space to reach Earth. Heat lamps in bathrooms or food counters warm objects directly using infrared radiation. Even remote controls use infrared radiation to send signals, the same family of waves as thermal radiation. Thermal equilibrium. Why heat flows. One way. Now, let's talk about a very important idea, thermal equilibrium. Heat always flows spontaneously from hotter objects to colder objects. This happens because fast-moving particles collide with slower ones and transfer energy. Eventually, both objects reach the same average kinetic energy. At that point, there is no net heat transfer. The system is in thermal equilibrium. Discussion question: metal versus plastic spoon. Let's pause and think. If you place a metal spoon and a plastic spoon into hot soup, why does the metal spoon feel hotter, even though both are at the same temperature? The reason is conduction. Metal is a very good conductor of heat, so energy transfers quickly from the spoon into your hand. Plastic is a poor conductor, so much less energy reaches your hand, even though the temperature is the same. Ordering the heat transfer process. Let's check your understanding. Here are the events involved in heat transfer. Put them in order. Objects are placed in contact. Particles in the hot object vibrate intensely. Energy transfers through particle collisions. Both objects reach the same temperature. The correct order is 1. Particles in the hot object vibrate intensely. 2. Objects are placed in contact. 3. Energy transfers through particle collisions. 4. Both objects reach the same temperature. That final step is thermal equilibrium. Summary. To finish, let's summarize what you now know. Temperature measures the average kinetic energy of particles. Heat is energy transferred due to temperature differences. Heat moves by conduction, convection, and radiation. All matter has thermal energy because particles are always moving. Systems in contact eventually reach thermal equilibrium. These ideas form the foundation of thermal physics, and we will keep building on them. If you enjoyed this video, don't forget to like and subscribe for more.